So on Wednesdays we are pink, the 2nd of December, the last month of 2020, okay? Yeah. I am wearing pink.
I can't stand
SOVA students will be able to, you guys will be able to write linear equations in point slope form. So we're going to learn what point slope form is, how to write equations in it, how to use it, all these good things, okay? This is sections 4, 5, and 4, 6 today. So first of all, point slope form. Well, do you guys remember slope-intercept form? You guys remember slope-intercept form? Okay. Y equals mx plus b was our slope-intercept form, okay? So this one was slope-intercept form.
Do we need to write that down?
No, I'm just writing it here as a reminder. If you want to, you can, but you definitely don't have to. Thanks for asking that. The point slope form is y minus y1. This part you do need to write down. Is equal to m times the quantity of x minus x1. Okay? So here's this formula. Y minus y1 is equal to m times the quantity of x minus x1. Note, the signs of the point on the line will always be opposite of the signs in the equation. So I want to talk about a couple of parts of this, okay? So point slope form is like a vehicle you use to get somewhere, okay? You use a vehicle to get places, right? Okay, the end destination is not the vehicle itself. The end destination is somewhere else, but you use the vehicle to get somewhere else, right? Like that's just kind of a general life thing, right?
Yes.
Okay, thank you. Okay, I thought I was going crazy. I thought maybe you guys were on mute or something like that. Okay, yes, Jaden.
What is this like symbol that we have in our paper, like on number 2?
Yes, it was supposed to be a fraction. And we'll have to clear that up in a moment. Yes, it's a new math symbol. You didn't hear about it? No. Okay.
It's a zebra.
So it looks like a what?
It's a zebra. It has stripes.
Anyway. Okay. So vehicles. Okay, we use vehicles to get other places. The vehicles on our end destination is a tool we use to get to our destination. Point slope form is a vehicle. Okay, it's a vehicle we use to get from point A to point B, from somewhere to where we want to go. So we use point slope form to get to slope-intercept form. We like slope-intercept form, y equals mx plus b. We love slope-intercept form. It's really handy to graph in. We know the slope, we know the intercept. They're very easy to point out. We like that form, y equals mx plus b. Now, sometimes we're not given the intercept. Sometimes we're given the slope, but we're also given a point. So when this happens, we use point slope form, and we get in our vehicle, okay? And you use it as your vehicle to get to slope-intercept form, okay? Now, we might notice some similarities here between slope-intercept form and point slope form and some differences. Here's some similarities. There's a y, a regular y, on the left-hand side of the equal sign. Point slope form, there's a regular y on the left-hand side of the equal sign. Another similarity, the m is on the right side next to the x. M is on the right side of the equation next to the x. Here's next to two x's though. Differences. There's no b. There is an x1 and a y1. Well, the x1 and y1, that's new. X1 and y1 just represent a point. That just represents a point. The other x and a y, without numbers attached, without a label, those stay x and y. Because in our slope-intercept form, we always end up having a y and an x still in the equation. So we have those in there, and they stay y and x. But we are going to replace the x1 and the y1 and the m. So if we're trying to take this point, okay, or take this equation is currently in point slope form. Y minus y1, let me write this underneath even. Y minus y1 is equal to m times x minus x1. This is in our point slope form. So here we should be able to say, okay, well, what is the m, the slope? Okay, for identifying the slope and a point that lies on it. we should be able to say, hey, the slope of this line is, what do we think? 3, because it's in the M spot. So now we can say, okay, well, what's a point on the line? Well, what's in the x1, comma y1 spot? And it is a 4, but I actually wouldn't say it's a negative 4. I'd say it's actually a positive 4. But wait, it shows up here x minus 4. But in our formula, it's x minus whatever x1 is. See, the actual point is the opposite sign there. And it's 4 comma what? 2. Very good. So the point is 4 comma 2. So the slope is 3. A point on the line is 4 comma 2. Now in this example, that's all we're doing is just identifying those. We're not actually using the vehicle yet to transport us. We're just saying, hey, here are some of the parts on the vehicle, okay? Here's some of the things, here's how to operate it, that kind of stuff. So on number 2, what do we think our slope is on number 2? 1/2, that's in the M spot, okay? We're used to the slope being with the x's, so we look to the number to the left of the x. Okay, we're used to looking right to the left of the x, okay, directly to the left of the x. Same thing here. Now here, so that was supposed to be a 1/2, okay? So you asked about number 2, Jaden did earlier. That's supposed to be a 1/2. The point, okay, so the x1, y1, that's a comma, there we go. What's the point here? What comma what?
1 comma 3.
1 comma? Negative 3. So here, for it to be a positive, for it to be y plus 3, it has to have a negative before that, okay? Because you're subtracting something, so it's really subtracting a negative 3, which turned it into a positive. Okay, questions on those two of identifying what the point is and what the slope is.
I don't care where you got the negative 3 from.
Yeah, okay. So, our point and slope form is y minus y1, right?
Yeah.
So we want to take, so whatever the y1 is going to be opposite of whatever we see here. So because it's negative 2, the y1's actually positive 2. Because it's positive 3, the y1's actually negative 3. Because if we were to plug it in to the formula, we'd have y minus negative 3, y minus negative 3, which turns into y plus 3.
All right.
Does that make more sense?
Yeah.
Great question. Any other questions on these couple? Okay. Now we're going to be given the point and the slope, and we're going to write the equation, but we're going to keep it in point-slope form. So we're going to be given the point and the slope, and we're going to keep it in point-slope form. We're not going to use the vehicle yet. We're just going to get in the vehicle. Okay, we're not going to drive the vehicle anywhere yet. We're getting in the vehicle, which is point-slope form. So if I'm given the point, negative 9 comma negative 4, and the slope is 2 over 3, I can put this in the point-slope form. Y minus y1 is equal to m times x minus x1. I'm going to keep writing that over and over again so we remember it. And I think that's a good habit for you guys to get into as well, continuing to write down this form until we remember it. Okay? Because this is something I'm going to ask you to memorize. So I think it's helpful for us just to continue to write it to help us memorize it. So if I'm going to write this in there in point-slope form, the regular y, the first y is staying y. Y minus the y value, y minus negative 4, is equal to m, 2 over 3, parentheses, x minus x1, whatever the x value is, negative 9. Any questions on how I plug those in there so far? Okay, Jaden? Okay? I don't know either then. Okay? Does it make sense how we plug them in?
Yes.
Okay? And so you understand why the negative 4 is where it's at, the 2 over 3 is where it's at, and the negative 9 is where it's at. Okay? Is your question, why are we doing this?
Never mind. I think there's a reason why I put my hand down right after braces.
Okay. Cool beans. So we still want to do one more thing before we say we're good with this. Let's take care of some of those double negatives. So what's y minus a negative 4? What's that turn into? Plus, okay? It turns into adding it. Okay, and what about x minus a negative 9? What's that turn into? Plus, we're adding it. Okay, this is our equation in point slope form. Okay, and for now, we're leaving it there. Okay, but in a couple steps later, in a couple problems later, we're going to add on the step of actually using the vehicle, driving the vehicle to slope-intercept form. Right now, we're just getting in the vehicle. Okay, we're getting in to point slope form. Okay, questions on number 1 at all? Okay, I want you guys to try number 2. Okay, when you have it or have questions, raise your hand.
What's the number?
I did miss you though. Okay, let's look at number 2 here. So as we plug this in, y minus 5 is equal to 1/2 times x minus negative 8. Now what happens with that minus and negative? Turns into positive. If you just want to call it x plus 8 right off the bat, you already see, oh, that's what's going to happen here. Then go ahead and do that, okay? Now you might notice the y coordinate, the 5, is with the y. The x coordinate is with the x. We're not mixing them around, are we? Okay, we're keeping the y's with the y's, we're keeping the x's with the x's, okay? We're trying to keep that part as straightforward as possible. I want you guys to go ahead and try number 3. All right, on this one, we're going to have y minus 2 is equal to 0 times x minus 1. Now, we might notice here, okay, I saw a couple of us even take this a step farther and say, well, 0 times anything is just 0. So it's going to be y minus 2 equals 0, okay? But you totally could. Right now, I'm just asking for it to stay in the vehicle, okay? But if we wanted to go the step farther, that's how you would do it. Now, number 4, this looks weird. We're given the slope, but are we given a point? We might think, well, no, we're not. Okay, well, we talked before when we had like f of x was equal to something. Okay, when f of x was equal to something, the output is really the y. So what it's equal to is really the y. And the input is really the x. So here, this actually is a coordinate 2, negative 3. The input, what we're putting in, is the x value, and that's 2. It's going in the function. And what we're getting out is negative 3. That goes back to last chapter, okay, when we plugged in something to a function and got something out. Do you guys remember plugging things into functions and getting things out? Yeah. Okay, I hope we at least vaguely do. Okay, so the 2 is actually our input, and our negative 3 is actually our output, our y. Now do we have the slope and the point? Yeah, can somebody volunteer to help me go ahead and write this in point slope form? Okay, go ahead, Courtney.
Y plus 3.
Okay.
Well, y minus negative 3, which will equal plus.
Yep.
And then equals 5 times the quantity of x minus 2.
Oh, I love it. I love that you even threw in times the quantity of. Well said, okay? So y plus 3, and as she stated, minus and negative turns into that, is equal to 5 times the quantity of x minus 2. Any questions on that one? Okay, so now using that knowledge, I want you guys to try numbers 5 and 6. So on number 5, can somebody help me with this? Jocelyn, thank you.
What? Oh, y minus 6 equals 1.
Nailed it. Y minus 6 is equal to 1 times the quantity of x minus 0. Very, very good. The 0 is the x, 6 is the y. Jocelyn did a great job with that. Thank you, Jocelyn. Okay, slap yourself on the back. Okay. Anyone want to help me with number 6?
That's a threat.
That's a threat. Yes, we did number 6 as well, okay? Eli.
You want me to just say it?
Yes.
Y plus 4 equals negative 2. And x plus 3. What's the...
You can say times the quantity of or in parentheses, okay? There's a couple of different ways you could say, or times the sum. So y plus 4 is equal to negative 2 times x plus 3, or times the quantity of x plus 3. And Eli did a great job with those negatives and making sure to change them to positives there, okay? Any questions on these 6? Okay, once again, this is setting up the vehicle to now use it to drive, which is what we're going to do next here, okay? So, linear equations in point slope form, which is what we just used, because we're given the point and the slope. That makes sense, guys? Point and you're given the slope, so you're going to use point slope form. Okay? I mean, it wasn't a joke. I mean, okay. Anyway, we can rewrite these. They can be rewritten in slope-intercept form. Yes. So, if we look here on number 1, okay, you might want to rewrite that kind of blob thing as 1/2. But on number 1, this looks to be in point-slope form. Do you guys agree?
Yeah.
Okay, I think it does. Okay, I think the point would be 6, 2. Our slope is 1/2. Now, in two steps, we can use this vehicle. Okay, we're going to get in the vehicle, okay, in point-slope form, and we're going to drive it over, okay, on your motorcycle, okay, and we're going to take it to slope-intercept form, which is our final destination. Okay, so here's what we're going to do. We're going to start off with distributing the slope. So y minus 2 is equal to 1/2 times x. Well, what is 1/2 times x? 1/2 x. Minus 1/2 times the 6. Well, yeah, half of 6 is 3. So y minus 2 equals 1/2 x minus 3. So that's our first step. Halfway done. Our second step is going to be to add the 2 to both sides. Now, when I add the 2, when am I going to combine it with the 1/2 x or the -3 when I add it to the right? I'm going to add it to the -3, yeah, because those are like terms. Either have variables. Very good, very good. -2 plus 2, that's 0. Does that get rid of the variable there?
That's -1.
On the left-hand side. -2 plus 2, that's 0, right?
Yeah.
So that gets rid of the variable, so we have y equals 1/2 x, and on the right side it is -1. So does this now look like slope-intercept form? So if we look at this, would we still know, okay, the slope's 1/2, but do we now know the intercept? Yeah. Okay, and we love slope-intercept form as far as graphing goes, okay? It's really handy for us. And so we did what it asked. We put it in slope-intercept form.
That's all we do.
Yep. This is actually the main function of point-slope form, to be honest, guys, okay? The main function of point-slope form is to use it as a vehicle to get us to slope-intercept. Okay, that's the main thing we want from it. Jaden, are you taking your question back?
Yep.
Okay. So we want to just use it as a vehicle to get to slope-intercept form. Now, if we recall, slope-intercept form, y is by itself, right? So we had to get y by itself. But before we did that, we had to distribute and simplify out that right-hand side. So on number 2, why don't you try that on your own?
I did it. Okay.
Alice, would you be so kind as to tell us what to do here?
So you distribute -3 with x and
Okay, so y plus 6 equals?
-3 times x plus 12.
Okay, very good, very good. Okay, and then finish it off.
And then minus -6 on both sides.
Okay.
12. And you get 6. And then bring the -3x down. And it would be y equals 2.
Nailed it. Thank you, Alice. So our first step is to distribute, which she did great. Okay, especially the negative times the negative there. And then we subtract the 6 from both sides to move the 6 from the left to the right. You get y by itself, okay? If we recall slope-intercept form, we need y by itself. So that's all we're doing is getting y by itself, okay? Question on this at all? Let's go and flip that page. So we're going to write an equation given the slope and the point, okay? So we're going to use slope-intercept form and we're going to use point-slope form. And I'm going to show you guys how you can actually do this using both forms, okay? So there's actually a way you don't have to use point-slope form, okay? We're going to still practice it, okay? We're still going to practice it because I want you guys to be able to. Some people end up finding it easier to not use it, and some people end up finding it easier to use it, okay? So I'm going to teach you guys both methods. Does that make sense?
Yeah.
Okay, so I want you guys to be able to do both, but I want to teach you both, okay? Abby, thanks for putting that away, okay? So, let's go over how to use point-slope form, okay? So we're going to put the slope in for m. We're going to put the point in for x1, y1. And we're going to solve the equation for y. That's what we were just doing, actually, okay? So as an example, let's say we have an m is 2. And we know it goes through the point. We can say it goes through the point 3, 1. So if we know the m is 2 and it goes through the point 3, 1, we use point slope form. So it'll be y minus 1 is equal to 2 times x minus 3. Okay, so we would put it into point slope form. We get in our vehicle. Now we're going to drive the vehicle to get it into slope-intercept form. So we plug things in. Now we're going to solve for y. So now we're going to drive the vehicle. So we're going to distribute the 2. Y minus 1 equals 2x minus 6. And we're going to add 1. Y equals 2x minus 5. Is that basically what we just did before? A moment ago? Yeah, we just had to put in the slope and the point. We kind of combined our two problems earlier, right? Of plugging it in and solving. Combined them.
Is that a negative 5?
Yes, that is a minus 5 there. Let me even rewrite this because that turned out pretty poorly. So we end up getting y equals 2x minus 5. Now we could do the same equation. We could get the same answer, okay, by using slope-intercept form to start with. So what you do is you put the slope in for m. So that part didn't change. This time we're going to put the point in for regular x and y. Because in slope-intercept form, y equals mx plus b, do we see an x1 and a y1 in y equals mx plus b? No. So the only place for the x and the y to go is normal x and y. And then we're going to solve the equation for b. And then we're going to put the m and the b back into the equation. So the thing we're missing in order to use slope-intercept form is the intercept. We have the slope. So we're going to find the intercept and then plug the intercept and slope back into the equation. So if we do the same example here, okay, where we're going to use m is 2 and it goes through point 3, 1, what we could do is say 1 equals 2 times 3 plus b. So we plug this into y equals mx plus b. Y becomes the y value of the coordinate, 2 is the m, and 3 is the x value, and b stays b. Now we're going to solve for b. So we say, okay, 1 equals 2 times 3 is 6 plus b. Now we subtract 6. And we get b to be negative 5. And we have one more step after we find b in order to get this into slope-intercept form. Now we know the m, which is 2, and we know the b, which is negative 5. So we can plug this in and say y equals 2x minus 5. That's much more similar to what we would have done previously. Hey, Riley. Much more similar to what we would have done previously versus what we do on the left. Do we get the same answer either way? Yeah, so we get the same line, same equation either way. Because it goes through a specific point with a specific slope. Two different methods to do the same thing. Questions? Make sense? Questions? Where are we kind of at? Give me some feedback here. Okay, thumbs up if you're kind of feeling good about this. Thumbs down if I completely lost you. In your Sunday best, okay? What? It is a really long section, yeah. Yeah, it is quite the lengthy section, okay? Yeah, it technically is too. It's like 1.5 because we did the first half of 4.6 before. So this really ends up being a little bit like 1.5, okay? So what we're going to do now is we're going to do what we were doing on the left-hand side up a moment ago. So we're going to write the equation line in slope-intercept form that passes through this point with the given slope. So our first step is going to be getting in the vehicle, getting in point slope form. Then we're going to drive the vehicle to slope-intercept form. Can somebody help me with number 1? Put this into point slope form. Somebody help me with number 1 to put it into point slope form. Okay, Courtney, go ahead.
This is like the y minus thing, right?
It is.
So y minus 7
Yep.
equals 3 times the quantity of x plus 1.
Nice. So y minus 7 equals 3 times the quantity of x plus 1. Or minus a negative 1, which turns into positive. So if we think about this here, we're given the point and the slope, so we're going to use point slope form. Now we got in the vehicle. Now we're going to drive the vehicle. We're going to drive the vehicle over to slope-intercept form by distributing the 3. Y minus 7 equals 3x plus 3. And adding the 7. Y equals 3x plus 10. So now, did we write the equation of this line in slope-intercept form? Yes, it is in slope-intercept form. Questions on that? All right, I want you guys to try number 2. So, on number 2, m is 1 over 3, and the point is 9 comma negative 4. So we have y plus 4 is equal to 1/3 x minus 9. We might think, oh no, we have a fraction. That's going to be a pain. Well, actually, it doesn't work out too badly here. As we distribute here, we have y plus 4 equals 1/3 x minus 3, because a third of 9 is 3. So now we subtract the 4, and y is equal to 1/3 x minus 7. So we get into the vehicle, point slope form, in the red there, and then we drive the vehicle in the green here over to slope intercept form. Questions on that at all? Okay, let's go through number 3 together here, and let's see what happens when we get some fractions, okay? Which is okay, it does happen. So as we plug this in, we're going to get y minus 9 is equal to 2 over 3 times x minus 5. We're going to plug this in the same way we've been plugging them in. And our first step's still going to be the same. We're still going to distribute. Y minus 9 is equal to 2/3 x. Now this does not simplify here. So this is really like a 5 over 1, which just becomes negative 10 over 3. And we just have to leave it as such. Now we go to add 9 to both sides. We might notice, oh, we need common denominators. Okay? Well, you can do this a couple different ways. You can write it in here in the actual problem, or sometimes it's easier for us to work this off to the side, saying, oh, I'm going to do negative 10 over 3 plus 9 over 1. And say, okay, well, I need common denominators, so I'm going to have to multiply the 9 and the 1 by 3. Now I'm going to have negative 10 over 3 plus 27 over 3. But it's going to give me 17 over 3, and it just stays like that. So you get y equals 2 over 3x plus 17 over 3. And even though it might make us a little uncomfortable being our answer because there's so many fractions there, it actually is our answer, and that's perfectly okay. So we still do all the same math we normally would. We just have to make sure we're dealing with our fractions and doing the right steps there, okay? Questions on that? Okay.
What was it, 6 instead of like 5? Would you 4? Would that be?
Yeah. If it was a 6, that would work out very nicely. Yeah. So if it was something divisible by 3, it would work out really nicely there. Yeah, good question. I like that you're thinking about that. Let's move on to number 4 here. What do we notice about number 4? Oh, Sarah, were you gonna say something? Oh, gotcha. Sarah, do you want to help me with number 4 actually?
Sure.
That'd be dope. Go ahead and help me plug it in.
Y minus 8
Yep.
equals 0 times x plus 4.
Yeah. Now, what might we notice here is going to happen? Okay? Courtney, what do you think is going to happen?
The zero's going to cancel everything in the parentheses out.
Yeah, the 0 is going to just make everything else go to 0 when it distributes. So we're just going to have y minus 8 equals 0. Because what's 0 times x even? Just 0. So we have 0 plus 0, which is just 0. So we have y minus 8 equals 0. Okay, well, is this yet in y equals mx plus b form? No, we still need to get y by itself, so we add 8, just like we would normally. We're still going to do the same steps. We just get y equals 8. And that's just the horizontal line, y equals 8. Okay, do you guys remember horizontal lines, vertical lines? Okay, horizontal line is y equals the number. Okay, questions on that?
Would that be unidentified or?
Nope, the slope is 0 because they were told the m is 0. If it was a vertical line, x equals a number, then it'd be the undefined slope. Yeah. Okay. Any other questions on that? Alrighty. You guys are doing great, okay? Let's go on to this next section here. Okay, right at the bottom of this page. Okay? So write an equation given 2 points. So sometimes we're given 2 points. We're told, hey, we have a line that goes through this pair of points. Well, how can we write the equation? Before we needed the slope. Either way, we were given the slope in the intercept or the slope in the point. Well, could we find the slope between these 2 points? Yeah, then we'd have a slope and a point. So our first step is going to actually be finding the slope, and then we're going to do all the same steps. So when you're given 2 points instead of the slope, you just have one extra step, which is finding the slope. Can anyone refresh my memory on how to find this slope? Okay, y2 minus y1 over what, Raquel? Yeah, to find the slope, m is equal to y2 minus y1 over x2 minus x1. Now, did it truly matter which y we put first? No, but the x had a match, didn't it?
Yeah.
Okay, so can anyone help me find the slope on number 1? Ava, do you want to help me? No, okay. Elijah, do you want to help me?
I'm not really sure what to do there.
Okay, well, we're going to do the slope formula, the y2 minus y1 over x2 minus x1, okay? Josh, you want to help me? All right? Okay, negative 2 minus 1 on top. That sounds great. So on the top, he did negative 2 minus 1. On the bottom, Josh did 8 minus 5. Now, could Josh have put the 1 on the top and do 1 minus negative 2? Yeah, on the bottom, he would have had to switch them around, though, right? Okay. So now we say, what is negative 2 minus 1? Negative 3. And what's 8 minus 5? 3. What does that simplify to? Negative 1. So our slope is negative 1. So now we know the slope. And do we have a point?
We have 2.
Actually, as a matter of fact, we have 2. So does anyone have an idea of what that might mean? Which one do we use?
Maybe go the y. Maybe
What?
go in between. No.
Maybe go between.
First one?
Maybe
First one,
do
second
the
one.
like the y1 and the x1 because you're using the y1 and x1 when you do that equation.
Okay, so you're thinking whichever one we end up putting second. Okay. How about this? It actually doesn't matter which point you choose. You get a pick. So we have to ask ourselves a question. Which one would we rather plug in? Okay, my dad always told me work smarter, not harder. Okay, do the thing that would make your job easier rather than just make your job harder. So would we rather plug into a formula 5 and 1 or 8, negative 2? I heard a couple different answers. Someone said 5, 1. Why would someone rather plug in 5, 1? I'll hear both sides.
Because positive numbers, you don't have to worry about any negatives.
Okay, positive numbers, you don't have to worry about negatives. Okay, are they also smaller?
Yeah.
Okay, typically we like smaller numbers. Let's talk about our bank count. Did anybody say 8, negative 2? Okay, maybe I'm just hearing things. Okay, so let's deal with the smaller numbers. So let's use this point. Okay, well, let's use this point and the slope. So we're going to put this in a slope, or point slope form. Y minus 1 is equal to negative 1 times x minus 5. Y minus y1 is equal to m times the quantity of x minus x1. We're putting it into point slope form. So everything in the blue and beyond is going to be the same steps we've done. We're now getting in the vehicle. Before, what we essentially had to do was we had to find our keys and get our bag packed. We had to find slope. All done? Mm-hmm. Thanks, buddy. Hey, Gregor, where'd the other sheets go?
That was it.
I gave you a calendar.
Oh, yeah, I'll bring that down.
Thank you. So we end up really having to go and find our keys, pack our bag. Then we say, okay, well now we're good to go. Now we're able to get in our vehicle in the blue. Questions on what we've done so far? Okay, so now at this point, we're going to drive our vehicle the rest of the way. So we distribute. Y minus 1 is equal to negative x plus 5. Good with that step? Bad with that step? Give me a thumbs up, thumbs down. Good with that step? Bad with that step? I want everyone's vote. Give me if you're good with that step I just did now. Okay? So from here to here, all we did was we distributed it, which was our first step from before. Now we're going to do our second of the two steps, which is adding the 1, getting rid of that number with the y. Y equals negative x plus 6. And that's our answer now. We successfully wrote the equation of the line between those 2 points. Yeah, Abby?
Could you have y equals negative 1x?
Yeah, you totally could have y equals negative 1x. Negative 1x and negative x, those are the same thing, yeah. Yeah, good question, okay? So once again, we just added on one more step from what we did before. On number 2, we're going to practice a similar problem, okay? But before we do that, number 2, we're given 2 points again, but they don't quite look like points. Do we remember the x-intercept and y-intercept?
Yes.
Okay? The x-intercept is when what value is 0?
Y.
The y value is 0. It crosses the x-axis. So this x-intercept is really 6, 0. What point is the y-intercept?
X.
The x is 0. So it's 0, 4. So do we have 2 points here? Let's see, let's write it down after. Let's forget.
Yes.
We have 2 points. So can we figure out the slope? Yes, we're going to grab our keys, pack our bag before we get in the car. Okay, before we get in the vehicle here. So let's find the slope in order so that we can get in the vehicle point slope form. Okay, Elijah, you don't help me this time with the slope?
Yeah.
Alrighty.
So the 4
Okay.
minus 6.
Ooh, not quite.
Wait.
We'll keep the y's together on the top. So 4 minus, what's the other y? 0?
And then it'd be 0
Mm-hmm.
minus 6.
Very good. 4 minus 0 over 0 minus 6. So if you put the 4 first on top, 0 has to come first on the bottom, or vice versa.
So it'd be
4
4
4 over negative 6. And does that reduce?
Yeah.
Yeah. Yeah. Negative 2 over 3. Does it matter where we have the negative? No? Cool. I'll put it on the top just for grins and giggles. Grins and giggles.
Friends? Much not even my grandma says.
Yes, yes. This is a school appropriate version. Okay? So now we got our keys. We packed our bag. Now we're going to get in the vehicle, which is point slope form. Can anybody help me get into point slope form? And we can use either of these 2 points, okay? Eli, go ahead.
Y minus 4 equals negative 2 over 3 times the quantity of 4. 0.
X minus 0. Yeah, so y minus 4 is equal to negative 2 over 3 times the quantity of x minus 0. So Eli chose the point 0, 4. Eli also could have chosen 6, 0 if he wanted, but he chose the quantity, 0, 4 the point. Either point would have been fine. Either point would get us the right answer. Now we distribute. We start driving the vehicle. Y minus 4 is equal to negative 2 over 3x minus 0. Do we even have to write minus 0? No. Okay, so now we add 4. And can we actually combine negative 2 over 3x and 4? No, but we can write it. Y equals negative 2 over 3x plus 4. And that's our answer. We will not do all the remaining examples. We'll do some of them. Okay? Questions on that? Alrighty. We're going to skip numbers 3 and 4. And we're going to move on to letter F, the last section of this part of the notes. The last part of this section of notes. Probably a better way to say it. So we're going to take this graph. Okay? We have this first graph. We have a line. We're going to learn how to write the equation of this line. So we're going to identify the slope of this line. So let's first say, what's the slope between these 2 points? What's the slope of this line? We did this earlier today on our homework that we turned in. Okay, so it rises 3, and what did someone say the run is? 4. So our m is 3 over 4, right? If you went the other way, you get negative 3 over negative 4, which is positive 3 over 4 again. Now, we want to identify the y-intercept, or the b. Who can tell me what the y-intercept, or b, of this graph is? Okay, Jaden. 2, very good. Typically, when we graph, that's where we begin. Remember? Now, sometimes the y-intercept is not a whole number. In that case, we would use point SOAP form. You pick a point and do point SOAP form. But here, now we write the equation just by plugging in m and b. So now we have y equals 3 over 4x plus 2. And that's our equation. If we were to see that equation and we were to try to graph it, we should get this exact graph. Begin with 2, a rise of 3, a run of 4. Looks like it's going uphill, positive slope. Questions on that? Okay. Let's look at this next one. What's my m here?
1 over 1, which is 1.
Okay. The slope is 1 over 1, but wait.
Negative.
Negative 1. It falls 1. So the m is negative 1. What's the b here? 4. So who can help me write my equation? Okay, Jaden, go ahead. Y equals negative 1x plus 4, or you could just do negative x plus 4. Either way. Very good, very good. The m is what goes with the x, and the b goes at the end.
Is that it? That's what we're doing.
Yep.
Really?
Yep. Now on this third one, we find the slope. What do we think our slope is on this third one?
4 over 1.
Okay. 1, 2, 3, 4. I agree. Over 1, 2, 3. Yep. So the m is 4 over 3 here. Is our y-intercept exactly on a whole number? No. So this is where it says, if it is not a whole number, choose another point and use point slope. So let's choose one of these 2 points. Which point would you rather choose? 1 comma negative 3 or 4 comma 1?
4 over 1.
Okay, I heard 4 comma 1. Let's do the point 4 comma 1. So now we're going to use point slope form. Okay, so on the first 2, we had the slope and the intercept. So we use slope intercept. Here we have the slope and the point, so we use point slope. That makes sense. You use whichever equation, whichever form, for whichever 2 you have. If you have point slope, you use point slope. If you have slope intercept, you use slope intercept. So we would take this and plug it in. Y minus 1 is equal to 4 over 3. X, or excuse me, times the quantity of x minus 4. And we would distribute like we have been. Y minus 1 is equal to 4 over 3x, and this doesn't simplify, unfortunately. It just becomes negative 16 over 3. I'll go ahead and shortcut our work here a moment and say when we add 1, we end up getting y equals 4 over 3x minus 13 over 3. Now you might notice, is our b, our y-intercept, is that a whole number?
No.
No, but we notice it doesn't intersect at a whole number, so that does seem to make sense, okay? And that is our answer. Questions on that?
No, sure.